Streamlining Kubernetes Management, a step-by-step guide to AWS Lambda and EKS integration. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Integrating AWS Lambda with AWS Elastic Kubernetes Service, EKS, is a powerful way to automate Kubernetes operations using serverless computing. This podcast will walk you through setting up authentication and performing cluster operations via AWS Lambda, from manual methods to automated token generation. Understanding AWS EKS and Lambda integration. AWS Lambda and AWS EKS are critical services in the AWS ecosystem, each serving a distinct purpose. AWS Lambda allows you to run code without provisioning or managing servers, while AWS EKS provides a managed Kubernetes service to run containerized applications at scale. Integrating these services enables serverless operations on Kubernetes clusters, offering flexibility and scalability in managing containerized workloads. Overview of AWS Elastic Kubernetes Service, EKS, and AWS Lambda functionality. AWS EKS simplifies running Kubernetes on AWS by handling control plane management, including patching, upgrades, and scaling. It also ensures high availability by distributing control plane nodes across multiple availability zones. AWS Lambda provides a serverless environment to run code in response to events, such as HTTP requests or changes in data states. It automatically scales your application by running code in response to each trigger. Prerequisites for integrating AWS Lambda with EKS. Before integrating AWS Lambda with AWS EKS, ensure the following. AWS CLI installed. The AWS CLI is essential for interacting with AWS services via the command line. Kubectl installed. This command line tool is necessary for managing Kubernetes clusters. IAM roles and permissions. Proper IAM roles should be in place to allow Lambda to interact with EKS. An existing EKS cluster. Ensure you have a running EKS cluster with worker nodes. Setting up the necessary permissions and configurations. To allow AWS Lambda to interact with AWS EKS, you need to configure IAM roles and permissions. Create an IAM role for Lambda. Attach the necessary policies, such as Amazon X Cluster Policy and Amazon X Worker Node Policy, to allow interaction with the EKS cluster. Configure trust relationships. Ensure that the Lambda service can assume the role by configuring trust relationships. Manual authentication process with AWS EKS. In the manual method, you authenticate AWS Lambda to EKS by manually generating a token and passing it to the EKS API server. Generate the token. Use the AWS CLI to generate a Kubernetes authentication token. AWS X get token cluster name cluster_name. Pass the token to the EKS API server. Use the generated token to authenticate your request to the Kubernetes API server. Exploring the manual method of authenticating with EKS API server. While the manual token generation method works, it could be more suitable for production environments due to the need for frequent token renewals. However, it's a good starting point for understanding the mechanics of EKS Lambda integration. Automated authentication for AWS Lambda functions. For production use, automated authentication is crucial. This can be achieved by generating and passing tokens programmatically within the Lambda function. Implementing token generation and usage in Python. Install the AWS SDK for Python Boto 3. This library allows you to interact with AWS services, including EKS. Pip install Boto 3. Generate token programmatically. Import Boto 3. def get _x token cluster _name. Client equals boto3.client_x. Response equals client.get token cluster name equals cluster_name. Return response status token. Use the token in requests. Incorporate the token into your requests to the EKS API server. Setting up AWS Lambda for EKS operations. To set up AWS Lambda for EKS operations, you need to prepare the function environment and dependencies. Define Lambda environment variables, include variables such as the EKS cluster name and the AWS region. Package dependencies, use AWS Lambda layers or package the dependencies within the Lambda deployment package. Performing cluster operations via AWS Lambda. Authentication lets your Lambda function perform Kubernetes cluster operations, such as creating, reading, updating, and deleting resources, CRUD operations. Create Kubernetes resources, automate resource creation, such as deploying pods or services. Update and scale deployments, use Lambda to scale deployments based on events. Delete unnecessary resources, automate cleanup operations to manage cluster resources effectively. Troubleshooting common issues. When integrating AWS Lambda with EKS, you might encounter common issues such as permission denied errors. Ensure the Lambda function's IAM role has the necessary permissions to interact with the EKS cluster. Token expiration. If using manual authentication, ensure that the token is valid for the duration of the operation. For automated setups, handle token regeneration gracefully. Addressing potential errors and limitations in Lambda EKS integration. Handling timeouts. Lambda has a maximum execution time of 15 minutes. Ensure that your EKS operations are optimized to complete within this limit. Concurrency limits. Be mindful of Lambda's concurrency limits, especially when automating large-scale operations on EKS. Conclusion. Integrating AWS Lambda with AWS EKS offers a powerful approach to managing Kubernetes operations serverless. By setting up proper authentication and leveraging Lambda's automation capabilities, you can streamline cluster management tasks and ensure efficient and scalable operations. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.